Good morning, guys. Um, Make sure before you watch this video on converting from polar to rectangular coordinates, make sure you have watched the introduction to polar video. Now, I know that is not one of my videos, but that is a very, very well done video and a video I've used in the past as a resource in my class, and many of my students found that to be incredibly helpful. If you have questions specific to that video, make sure you let me know. I'm going to try and deal with some of that stuff as we're working through it here today, or some of these conversion ones. So as you can see, what we're looking at here in this video is our directions say convert each pair of polar coordinates to rectangular coordinates. So when we look at polar and or polar and rectangular, though their grids look different, they can still be converted back and forth. In fact, let me get this going. Why is my, oh, that's the wrong, I'm using a pen on my computer. Uh, if we look here, even though this is a polar grid which uses rings instead of a rectangular grid like what we're used to, this is still quadrant 1. I'm going to move this a little closer to me. This is still quadrant 2. This is still quadrant 3. And this is still quadrant 4. That does not change. We're not changing that aspect of it. But we're looking at, say, for example, number 7. I want to plot number 7. Right? Number 7 says we have a radius of 2 and we go 2 pi thirds. So I find my angle. I'm going to highlight my angle. Here's 2 pi thirds. And I go out on my angle a distance of 1, 2. So here's the point for number 7. I'm going to label that there. Now the reason I'm just practicing plotting is when you're converting, it's nice to see where this is because we can kind of check our answer when it comes to converting. Now, when you're converting from polar to rectangular, remember what we're looking at here is r and theta, right? And we're trying to get this to be converted into x, y. That's rectangular. The formulas we use for this is something you're going to recognize. X equals r cosine of theta, and y equals r sine theta. Now, the way I remember this is remember when we're working with the unit circle, cosine is given with the x value and sine is given with the y value. That's kind of how I remember this, but you guys will be able to use a formula sheet for this anyway, so it's not really a huge stress. So let's convert this. We're converting this to xy. So first let's find our x. X is equal to my r value, 2 cosine of 3 pi halves. Now this you can evaluate directly in your calculator, or you can use the table that I've given you. If you use the table, cosine of 3 pi halves, I believe, is going to be 0, right? Yep, 0. So it becomes 2 times 0, which is 0. And our y value, y is equal to 2 sine of 3 pi over 2. And if I simplify this correctly, sine of 3 pi over 2 is negative 1 from our table. 2 times negative 1 is negative 2. And if we go to check, so let's go pretend this is a coordinate grid, right? If this is a coordinate grid or a rectangular grid, notice I'm going to the left and right, like 0, because that's my x coordinate, and I go down 1, 2. Notice we're in the exact same location. 0, negative 2 is the exact same marked location as 2 comma 3 pi halves. Same exact thing. Great way to check your work. Now, what I would like you guys to do is I'd like you to pause the video, and I would like you to, 1, start by plotting point 8. See if you can plot on our coordinate grid 0.8. And I know that's kind of tough because, well, you guys don't have a uh, something as fancy as I do, but that's okay. I'm sure you guys can manage. Try something. All right, so let's check to see how you guys did. Our coordinate here is 1 5 pi 6. So I'm going to go to the ray for 5 pi 6, and I'm just going to kind of draw that out. This just kind of helps me keep track of my angle. And then I'm going out a distance of 1. Boom. Here's my coordinate right there. I'm a little off, but I think you guys kind of get the idea. There's my coordinate. This is coordinate for 8. Remember, the ray really has nothing to do with it. I just use that to help me plot my point. In fact, I'm going to erase the ray. Boom. There's my coordinate right there. Man, I love this new pen. So let's see if we can find what x and y are. Now what I want you guys to do, see if you can pause the video and calculate what x equals and y equals. And we'll check. So again, x is equal to our r value, which is 1. In fact, I'm going to label that r is the first one, theta is the second. 1 times cosine of 5 pi, oh, sorry, 1 times cosine of 5 pi 6. And then y is 1 times sine of 5 pi 6. So if we go to our unit circle, at 5 pi 6, the coordinate should be negative root 3 over 2, and then our height should be positive 1/2, right, because that's the sixth. So cosine, remember, is again the x value. So this is 1 times negative root 3 over 2, and that's times, and this is negative. So that means our x value, I'm going to put it down here, our x value is going to be negative root 3 over 2. And our y value is 1 times the y value, which is 1/2, which is 1/2. Notice here how I gave exact values, right? Exact values are going to be very, very helpful for us. Since we have that table, I kind of expect it. If you give me a decimal approximation, I'll still take credit for it, but as we start to advance this material, it becomes critical that we know this is square root of 3 over 2, not the decimal approximation, which is like 1.4 something. So we go and check, right? This one's a little bit harder to plot, but what we can tell is we can tell, well, this is in the the second quadrant, and our answer is also in the second quadrant. So that's a good way. It's not a really exact way of checking it, but it's a way that to verify whether or not we've completed the math in terms of positives and negatives correctly here. Well, I hope you guys found that video helpful. Converting from polar to rectangular is going to be very, very helpful for us. So let me know if you guys have any questions. Reach out to your math teachers if you have any questions. I hope you guys are having a great day, and I'll catch you in the next video. If I can find my cursor, there it is.